Now in this lecture, we are going to look at how the algorithm of deleting a node from a CircularLinkedLis works. Now here, we create a method which takes as a parameter location. So this location parameter identifies that from which location we want to delete a node. We want to delete a node from the beginning of CircularSinglyLinkedLis, or we want to delete from the end of CircularSinglyLinkedLis, or we want to delete a node from any given location in CircularSinglyLinkedLis. Now by using this location parameter, we are going to identify it. Now the next step is we are going to check that if our CircularSinglyLinkedLis exists or not. So we are going to do so by checking head value over here. So if head in CircularSinglyLinkedLis equals null, it means that this CircularSinglyLinkedLis does not exist. So in this case, we cannot delete any node from a CircularSinglyLinkedLis because our CircularSinglyLinkedLis does not exist. So this means that our algorithm will terminate over here. Now otherwise, if head is not equal null, then we will continue to check location parameter. So if location parameter equals first, so this means that we want to delete a node from the beginning of CircularSinglyLinkedLis. Now we mentioned that in this case we have two cases over here. In the first case, we are deleting a node from CircularSinglyLinkedLis in which we have only one node, and then in the second case we are deleting a node from the beginning of the CircularSinglyLinkedLis in which we have more than one node. Now in case we have only one node in our CircularSinglyLinkedLis, then in this case we are setting head reference to null, tail reference to null, and first node's next reference to null. Now by setting head and tail references to null, we are deleting a link between head to the first node and tail to the first node, and by setting first node's next reference to null, we are deleting a link between first node to itself. When we do so, the first node is not referenced by any node, so this means that the garbage collector can delete this from the memory. Now in the second case, in which we have more than one node in our CircularSinglyLinkedLis, this means that the first thing that we are going to do, we need to change head reference to point to the second node. Now in this case, if we access the first node's next reference, it means that this is second node, so we are setting this to head, and then we have to change the last node's reference to point to first node. Now in this case, you see that in head we have first node's reference, so if we set tail.next, we are setting last node's next reference to head. So with this, the first node is not referenced by any node, so this means that the garbage collector come and delete this node from the memory. Now after doing so, our algorithm terminate over here. Now the next step is we are checking location parameter one more time. So if the location parameter is not equal to first, then we are checking it if it is equal to last or not. So if it is equal to last, this means that we want to delete a node from the end of CircularSinglyLinkedLis. Now here also we have two cases. The first case is we have only one node in our CircularSinglyLinkedLis, and the second case is we have more than one node. So if we have only one node, this means that this operation is same as this operation in which we are deleting an element from the beginning of CircularSinglyLinkedLis. So it means that if we have one element in our CircularSinglyLinkedLis, this element is the first element and this element is the last element also. So by setting all references to null, we can delete this element from the end of CircularSinglyLinkedLis. Now the next case is in which we have more than one element. Now in this case, the steps are different, so we have to loop through the linked list until we reach the node which is located before the last node, because we are going to delete the last node, so we need to stop before the last node. Now when we reach the before the last node, we are going to set tail to this node, and because this is going to be the last node, and then current node's next reference has to point to first node. So by setting current node dot next to head, we are creating a reference between the current node to the first node. Now with this, the link between the last node and the first node gets deleted, and the link between tail and last node gets deleted. So in this case, the last node is not referenced by any node, so this means that the last node can be deleted by a garbage collector. So it's going to be destroyed by garbage collector. Now after doing so, our algorithm stops over here. Now the last case is we are deleting a node from any given location. Now we are going to loop until we reach the node which is located before the node that we want to delete. Now when we reach that node, we are going to change that node's next reference to point to the node which is going to be after the next node. So this means that by updating current node's next reference to the node that's located after the next node, we are deleting a link between current node and next node. So this means that the next node will not be referenced by any node, so it's going to be deleted by garbage collector. So with this node gets deleted successfully, so our algorithm terminates over here. Now, as you see in our algorithm, we have combined all three cases in one algorithm. Now, based on this algorithm, we are going to create delete method in the next lecture. So by creating this algorithm, creation of a method in the next lecture will be much more easier. So hopefully everything is clear about this algorithm over here. Now see you in the next lecture.